Okay, we are starting a new chapter now in grade 9. Today is March 3rd, 2020, and we are beginning chapter 6 on graphing linear relations and interpreting linear relations. So these 4 questions would have appeared in grade 7 and or grade 8. And the process that you used in grade 7 and 8 is the exact same process you are going to use in grade 9. The only difference is when you create your equations, you might have decimal coefficients or decimal constants or negative coefficients and negative values. So there are there are slight variations to it, but the process for this chapter is identical to what we would be expected to be able to do in grade 7 and 8. So the first question gives you a table and asks you if x is 100, what's y? Now the first thing we need to say is that all of these parts here, this one right here, this is what we would call an ordered pair. And in grade 7, you learned an ordered pair is the x-coordinate is 1 and the y-coordinate is 10. And if I was to take that ordered pair and take a graph and put x is 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 110, actually I should probably go up by 10, so we'll make this 10. Sorry, I can't make that 10. It's important that if you make your axis, the spacing between where it starts and where that first line is, if I'm going to make that 5, then every space in between there has to also be a distance of 5, unless you use the breaking tool, which I'll show you later on. So we have this as our y-axis. This is always the y, and this is the x-axis. So this ordered pair, 110, would go right here on that graph. The second ordered pair, I was to move this highlighting down, 215, actually I'll just put in brackets, this is 110. 215 would be right there. It's 2 on the x and 15 on the y. And the third one, 320, would be right here. And what we see when we graph that is that those 3 points on that table, when they are graphed, form a straight line. Okay? And any point that would be before that and any point after, as we're going to learn later on in this chapter, would also fit onto that table of values if we were to extend it. So what we are actually asking you to do is if I extended it all the way to 100 and extended this all the way up, what would, if x was 100, what would the corresponding y value be that would be on this line? And the way we do this is we have to find the equation. And to find the equation, there is a relationship between x and y where we manipulate x by multiplying or adding or subtracting or dividing something from x to get the y value. And what you learned in grade 7 and 8 was if you look for the differences, in this case the difference in the y column is going up by 5 each time. And then you look for the differences in the x column, which is going up by 1 each time. What you learned was that the difference of y, the difference in the y, divided by the difference in the x, will equal your coefficient. Now it looks complicated, but it's not that bad. So if I think about that, the difference in y is 5, the difference in x is 1, and 5 divided by 1 is 5. So that means the coefficient in the relationship between x and y will be 5, meaning I am multiplying the x value by 5. Okay? So now that I know my coefficient, I go back to that first ordered pair, or any ordered pair, it doesn't matter which one I choose. I'm going to go back to the first one, and I'm going to take those x and y values, and I'm going to take the x value and substitute 1, and I'm going to take the y value and substitute 10. And when I simplify this multiplication, I get 5 equals 10. And since I know 5 equals 10 is not true, it requires a constant to balance the two sides of adding 5. So that means that the equation that represents each of these 3 ordered pairs that I know, plus every other ordered pair that would fit onto this line, is I take the x value, I multiply it by 5, and I add 5 to get the corresponding y value. Okay? And that will work for every number. So, going to the last part with the question that here, if x is 100, what is y? So in order to solve that, all I have to do is take my equation, substitute 100 for x, and I will find that the corresponding y value is 505. So if I go all the way over here, way down there for x is 100, and all the way up here, I will find that when x is 100, the y value that corresponds to it on this line that goes forever will be 505. Our next question gives us a table of values again and asks us to find not only the missing y value, but also a missing x value. And this is the same process. So the first thing I'm going to do is find my difference in y divided by my difference in x. And before I even do that, I always physically write a blank template with the relationship between x and y, leaving a space for a potential coefficient and space for a potential constant. So before I actually go looking for anything, that's the first thing I do. The difference in y is going up by 20, so I use a positive 20 there. And the difference in the x is a positive 2 each time. So 20 divided by 2, the difference in y, which is 20, divided by the difference of x, which is 2, is 10. And that means the coefficient in whatever the relationship is between my x values and y values is multiplying x by 10. Take an ordered pair, doesn't matter which one you choose. It's usually easiest to choose the first one. Take the x value of 2 and substitute it there for x. Take the y value of 10 and substitute it there. And when you look at this, 20 does not equal 10, so a constant is required of subtracting 10. So the equation that represents every single ordered pair that we know, the three ordered pairs that we know, this one, and this one, the three that we know, if I take the x value and multiply it by 10 and subtract 10, I will get the corresponding y value. So 6 times 10 is 60, minus 10 is 50, 4 times 10 is 40, minus 10 is 30, and 2 times 10 minus 10 is 10. So because those are all true, when I slip down to this one, if I substitute 100 into here, so 10 multiplied by 100 minus 10 is 1,000 minus 10, which is 990 for the y. So that means the corresponding y value is 990. Excuse me. Now, some people don't know what to do when the x is not given, but rather in this case the y. So if I take my equation here, and this time what's given to me is not the x value, but rather the y value. So I take that equation and I substitute y for 8,400. And all I've done is I've created a very simple grade 7 algebraic equation with simple coefficients and constants that when I add 10 to both sides, I get 10x equals 8,410. And when I divide both sides by 10, I get x is equal to 841. So the corresponding x value, therefore, when x is 8,400, when y is 8,400, when I simplify it, I could find out the corresponding x value using algebraic isolation is 841. Your third question did not give you a table of values, but rather gave you a graph. And it says, what is the equation? So for this one, what you're actually going to do is you're just going to create a table of values from the four ordered pairs you know. And if I look at this dot right here, this dot right here represents x is 1 and y is 22. The second one is x is 2, y is 24, x is 3, y is 26, and x is 4, and y is 28. So if I graph those three happy face ordered pairs, that's what I get for an equation. I'm still going to use that difference in y divided by the difference in x formula to get my coefficient of the relationship. So I put x is equal to y. This is my partial equation. Since the difference here is adding 2 and the difference here is adding 1, 2 divided by 1 is 2, which means my coefficient is 2. Once I have that, take an ordered pair, substitute it into your partial equation. If it's equal, if both sides were equal, you don't need a constant. But because both sides aren't equal, the constant that's required to balance it is adding 20. And therefore, the equation that matches this line, in which all of those points are on, is multiplying the x value by 2 and adding 20 to get the corresponding y value. So we could predict if we were to extend this line a little bit, and I was to put another happy face, just borrow this one here, and I was to put it on where 5, I could predict that because it's on that line, the corresponding y value would be 30, and that would be true. And your last question gives you an equation and a blank graph and no table of values and says graph it. So in this particular situation, all we have to do is we don't care what these are. It could be anything. We could make this, we could put a little break mark here, which means we shorten it up. And we could put a little break mark here, which means we shorten it up. And I could put 10, 11, 12, 13. I could put whatever I want there if I wanted to. But the easiest way to do it is to simply call this 1, 2, 3, 4, and 5. And what that means is because this is the x-axis, I'm going to put 1, 2, and 3 here. And if x is 1, 2, or 3, if I substitute x as 1, the corresponding y value, when I substitute 1 into my x value in my equation, gives me a y value of 3. When I substitute 2 into my equation, I get y equals 5. And when I substitute 3 into my equation, I get a y value of 7. Okay? So 3, 5, 7. So what I'm going to do here is I'm going to graph these 3 ordered pairs. What I'm going to do is I'm actually going to just make my spacing a little bit different, but I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 3 is right here. 2, 5 is right here. And 3, 7 is right here. And it is a linear relationship because when graphed, they form a straight line. If I was to continue this line forever, I could then plot any value of x greater than 3, 4, 5, 6, etc. And if I was to go through this, I could actually even plot negative values of x and negative values of y if I wanted to, because that line will extend to infinity in both directions. And that is the graph for your line.